Here is Chandler Smith with the talk titled Better Benchmarks, a Roadmap for High-Stakes Evaluation in the Age of Agentic AI.
All right, so I'm here to talk about benchmarks. I'm here to talk about benchmarks specifically in multi-agent systems. We've heard a lot over the last several days about things like agents, how they're being deployed, and how we're thinking about measuring and evaluating them. And my core point here and my goals for these presentations are threefold. First, I want to cover that there are unique risks presented by the deployment of agents and multi-agent systems. Second, I want to convince you that benchmarks and evaluations are key to developing regulation and policy that can help shape a successful future with agents. And third, I want to put the ownership onto you all to think about how we go about approaching benchmarks, developing them, and who the core responsibility is to build these systems. To achieve these goals, I'm going to go through 5 things. First, what is an agent? Second, I want to talk about how they're being deployed and they're proliferating through society. Third, I want to introduce what are specifically the risks presented by multi-agent systems. Fourth, I want to talk about the state of benchmarks and evaluations. And lastly, I want to provide some very specific recommendations for policymakers and government officials to think about how we regulate these systems. So agents. Agents are, and there's really no canonical definition of what an agent is. But the way that I interpret and understand agents is it is something that can take an action to update the state of an environment. The way that's played out recently can best be explored with this idea that Joshua introduced yesterday, which is the difference between a scientist and an agentic system. So as you look to the right of the screen here, you'll see Anthropic's web browser. So something that can actually take actions within a web browser. And to me, this highlights exactly the transition point from when we get something like a chatbot, where I'm talking back and forth with the language model, to something that can actually go and take action within a society. A couple other nomenclature things. In that scenario where I'm instructing a chatbot to go out and do something, I am the principal. So I'm the thing that's shaping the agent's behavior, the goals, or describing what I want to happen. Last nomenclature thing, I want to talk about failure modes and risks. These are problems. They cover the spectrum of, as we heard yesterday, that Anka Dragan described, societal risks versus something like systemic risks. And multi-agent risks span the entire spectrum, from data privacy issues to things that threaten our existence. So how are they being deployed? I think there's an argument that we want to discuss, which is whether we should at all deploy agents. I don't spend a lot of time thinking about this because we just are in an agentic world. We are seeing this happen. We are seeing models being deployed out and in the open. This is happening. We are here. It's happening at increasingly high-stakes situations. As you can see on the right-hand side of the screen, you have Palantir, who deploy their AIP, their AI platform, for enhanced AI-supported decision-making systems in military contexts. This is an example of agents in the wild. Furthermore, it's extremely easy to go and deploy it. It's the click of a button. There are dozens of startups and the major players all developing ways and mechanisms that basically have this loose understanding of take a foundation model and attach tools or very specific protocols to enable it to take action. And this is happening at a faster and faster rate. So now we've defined an agent, we've decided that we are in an agentic society and that this is happening. So what are the risks posed by these systems? How do they differ from single agent alignment, and why should we care about them? So I work at the Cooperative AI Foundation, and one lens with which we view agent interactions is through the lens of cooperation. So here I outlined 3 key failure modes, which is what ways is this going to go poorly, and in what way can they be shaped by the lens of cooperation. So when cooperation is desirable and agents share objectives, the failure mode here is miscoordination. When cooperation is desirable, and there's this mixed motive standpoint where agents might have collaborative goals and their own to keep into account, we get cooperation failures and conflict. And lastly, when cooperation is undesirable, but agents find a way to do it anyway, we get collusion. So let's go into this in a little bit more detail. What is miscoordination? So miscoordination is specifically when agents fail to work together despite having shared goals. One way that we highlighted this risk in our upcoming report on the risks of multi-agent AI is by running an experiment where we trained a couple of GPT 3.5 models. We trained one on driving data from the US and fine-tuned another on the driving data from India, opposite sides of the road. And we gave them a shared goal of avoiding and yielding to an emergency vehicle. And what we found was that the base models of 3.5 were able to coordinate quite effectively with only a 5% failure rate. But with the fine-tuning and the differences in data and the fundamental differences in the models, what we see is a failure rate of 77.5%. The second risk is conflict. So conflict specifically occurs when agents with different goals fail to cooperate. In recent work by Piatti et al. And the GovSim benchmark, what you see is you put a bunch of agents into some classic game theory resource sharing scenario, such as managing a fishery. And you put them in and you challenge them to coordinate. And under optimal conditions where they have the ability to communicate with each other, they found that even the most performant models that they tested, which is GPT-4o, that they failed almost half of the time. Failure in this instance means they depleted the resources all the way down to the point of failure, like complete destruction. The last is collusion. So collusion happens when agents are able to collaborate and we don't want them to. You can imagine this coming up when you have private information or ways when they're trying to work around a system to achieve optimal performance. An example of collusion is steganography. Steganography is the idea of hiding cryptographic messages and also hiding the fact that you're sending those messages. In recent work by Motwani et al., we see that not only are agents capable of steganography, that they can do it and hide it perfectly in the presence of an overseer, but that as models continue to develop and get better, they also get better at actually performing the steganography. So I teased a little bit earlier this idea of an upcoming report that the Cooperative AI Foundation is going to be releasing. The following are very specific mechanisms or risk factors. So what conditions lead to these type of failure modes that are inherent to multi-agent systems? I don't have time today to go into the detail, given that we only have about 20 minutes, but I wanted to tease these ideas to get your attention on the report next week and to explain that we have a very detailed understanding and a very first pass at figuring out what conditions lead to multi-agent failures. So now that we have an idea of what agents are, that they're here, and that we have a bunch of risks associated with them, what are we doing about it? How do we think about regulating these systems? So now we go into the core, which is benchmarking and evaluation. So why does this matter? Fundamentally, we cannot regulate what we cannot measure. It is imperative that we figure out measuring these risks and the presence of these capabilities and propensities in models before we're able to actually take action to regulate. So here's in an ideal world how I imagine benchmarks and evaluations work with policy. You have this virtuous cycle of benchmarks, which measure propensities and capabilities, that inform the policy that defines how we deploy models and what models we can deploy, which then inform the benchmarks that we make. Benchmarks aren't perfect. There are a number of limitations. And I point you to Anka's presentation later today that covers a lot of the richness behind what makes a good benchmark, how do you design it well, and what are the current limitations of modern benchmarks. You probably haven't heard of too many multi-agent benchmarks. In fact, you probably haven't even heard of too many multi-agent risks. I imagine that a lot of this information today is relatively new to you all, but yet you're richly familiar with the idea of single agent alignment and the work that's going on to develop safe individual systems. So I fundamentally think that's true for 4 reasons why these multi-agent risks are neglected. One is momentum. The best perception of AI alignment is really internalized through an individual model. And our science fiction narratives and our educational narratives really point to the things that we can do on an individual AI model scenario that helps inform the research that we do. So that leads to this momentum in the cycle of producing good research. Other people read it, they get ideas, and they start building off of that. And there's this wonderful web of really amazing scientific research that's happening with single agent alignment. We're at the very beginning of this with multi-agent research. We are just starting to build our momentum where things are going to proliferate. And you're going to see, because of the realities of agentic deployment these days, that we're going to continue to expand and build this momentum. But it hasn't really begun yet. Second is motivation. It's pretty clear who owns the alignment of something like GPT or Claude. It's the individual model providers. But who owns the alignment of multi-agent systems? What happens if you put GPT and Claude in a room together? These questions are not going to be answered by the providers because it's unclear who owns them and who owns the alignment of these systems. This is fundamental to why we haven't seen this research coming out at the same rate as we see single agent alignment research, because the motivations of the individual providers is just not there. Difficulty. Measuring multi-agent systems is hard. It's sort of like combining game theory with the most advanced technology today. There's a lot of complex things, and developing a benchmark that actually demonstrates what you're trying to measure is quite difficult. And lastly, direction. I think you can think about these problems, come up with one or two maybe intuitive ideas, but the field of multi-agent benchmarking and evaluation lacks direction. It lacks this vision of what are the problems that we want to solve and how are we going to solve them. The report coming out by the Cooperative AI and colleagues is really about designing this direction, taking the first pass at our best understanding of what these risks are and how we go and produce work to go and solve them. I do want to say that there is hope. Multi-agent research is wonderful in a few ways. Primarily, you don't need access to proprietary information or individual model weights to figure out how these models behave in multi-agent scenarios. So while it is difficult to come up with the exact evaluation metrics, these models are accessible for us to use. It is really about trying ideas and iterating. It can be expensive, yes. It can be hard, yes. But these models are available. And so the opportunity for things like government entities, nonprofits, and sort of individual academic researchers to research these issues is actually there, and it's present and it's accessible. So we do have a few, as I said, the bud of the momentum that's building. We have a few evaluations that I want to go through and what they show. The first of which is research that I did with some colleagues like Anka and others from Stanford, which evaluated where you put AI agents into a scenario where they had a finite action space in sort of like a diplomacy world scenario, where you basically said you can do any action from creating a peace treaty to all the way down to nuclear attacks. And we put several of these models all in together, and we wanted to see on a turns basis how this played out. What we found was concerning. What we found was that these language models tended to escalate at extremely high rates. In fact, all 5 of the models that we tested did show escalation tendencies, and it was hard to predict when they were going to escalate and how and why. Another example of an evaluation came from Jones, Dragan, and al. And really what it showed is, even if you have a strong model with really strict safety parameters, that strong model was able to utilize weaker models with less stringent safety parameters to go and actually achieve the task that it wasn't able to be instructed to do. And this is central to the idea of single agent alignment and just understanding that aligning single agents doesn't ensure that the alignment of the whole system or multi-agent systems is there. So what should we do about it? We now have agents, we know there are risks, we know that benchmarks and evaluations are important. So what should we do? First, I want to talk about what's going to happen next. So as I mentioned, we're going to introduce a report that helps set a direction. These issues are being acknowledged by things like the EU Code of Practice and are generally more conversationally acknowledged as we get to more agentic systems. And what I think we need to do next is develop really robust and ever-changing governance frameworks and infrastructure. And that's your job. So what specifically should we do? We should design evaluations that cover the systemic and societal risks of multi-agent systems. We should test for new and improved dangerous capabilities in multi-agent settings. And we need to create open-ended simulations to understand the different effects and dynamics of things like selection pressures and emergent behavior and the risk factors that I outlined earlier. Just want to take a moment to thank IASEAI and my colleagues at the Cooperative AI Foundation and all our collaborators for the incredible work to build this. Thank you.
one of the three aisles in front of a microphone, and we'll alternate between microphones. Any questions? Going once? All right. Well, in that case,
I have a question, actually. Could you just go back to the slide that you kind of glossed over and said, here's a list of risks, but I'm not going to talk about them now? Because I'd like to hear about that.
Yes, absolutely. So these are risk factors. So these are essentially what are the environmental conditions or the different things that can come about to create the failure modes that I outlined earlier. So I outlined 3 failure modes based on sort of like, all right, are your goals aligned? Are you in a mixed motive setting? Or are you in a purely competitive setting, et cetera, et cetera? So these specific mechanisms or risk factors, there are 7 of them. Information asymmetries. So as you think about the difference between knowledge or performance in agents, this could enable power dynamics or things like manipulation, and basically is a condition that could lead to misaligned behaviors amongst agents. You have things like network effects, which is the idea that one perturbation within a network can spread to the entire network. Think of misinformation in social media. If AIs are rewriting articles, right, any misinformation will get spread and proliferate. Think about selection pressures, which are more of the competitive conditions that can create and put pressure on agents as they behave in a system. You can think about destabilizing dynamics, which is one thing shifts another, and sort of you have this unstable ground. And if you think particularly like a military escalation scenario, right? These things can be unstable where one action can lead to the instability of the system as a whole. You have commitment and trust. So commitment and trust you can think of as I can make a contract or I can make a credible commitment that can be used for things like extortion, which is like I'm going to send this protocol to a website saying if you do this, this is going to get executed and there's nothing that can stop it. Another idea is emergent agency. So how can agency emerge from a collection of agents, or how do you think about emergence as more than the sum of its parts? So if you have individual agents, what could happen during their interactions that might be more performant? Is this a way to potential ASI? And last, you have multi-agent security, which is the interactions between agents unlocks an entirely new landscape for how we think about vector attacks, how we think about backdoors, how we think about the security of these systems and protecting our agents out in the wild from a principal agent standpoint and or their interactions between them. So that's a quick highlight, but I really want to encourage reading the report that's coming out in the coming weeks that goes into details, chapters, examples, and definitions of all of these different risk factors. Does that sound good?
Great, thank you.
Could you speak to the positionality of benchmarks with respect to multi-systems, in particular, like whose perspective the benchmark would be representing, like the collective systems or the individual, and like. Sorry, you're smiling, so I think it makes sense to you, and I'm glad because I'm not sure it makes sense to me as a question, but I'll let you run with that.
Yeah, I think this is like a fundamental problem of when the ownership path isn't clear, right? So we can generally agree that agents out in the society could lead to bad things that we don't want to happen, but the responsibility of how we regulate those is unclear. So if you're designing a benchmark to say, will your agent book up every restaurant in Paris to make sure that you have a reservation for Saturday and nobody else can get a reservation? So implementing a benchmark that might test for that kind of behavior is somewhat hard. And why would you want to include that in your system if it offsets performance? So if I understand your question correctly, it is like about the confusion of from who's responsible for coming up with the ideas of benchmarking and like who is it supposed to serve? Is that?
Yeah, effectively. Thank you.
Okay. Yeah. I think the responsibility is on bodies that have motivation to secure public good. So governance frameworks, academia, nonprofits, et cetera, who are motivated by stability and making sure there's a set of norms and protocols that prevent misaligned behavior. In terms of defining or designing that misaligned behavior and deciding what it is, I think this needs to be a public conversation in a public forum. Yeah, I don't have a great answer for you because I think that's one of like the core challenges of this ownership problem.
Yeah, and then the alternative would be it's a benchmark measuring my agent's entry into the joint system where there would be other agents, and how well does it perform for me in those negotiations or whatnot. You're looking at the joint side of things.
Yes, I think you can look at the individual properties of a model and think about its willingness to be cooperative, for example, and that can be an individual model question of saying, how does this model, when it gets thrown into this problem or in this scenario, how will that model perform? And then how do we design that model to be more cooperative or collaborative? And then there's, how do you look at a system to make sure that equilibrium is something that has appropriate mechanisms like scalable oversight? So I think both are extremely relevant. And that's actually a fabulous point because it can inform what we learn by looking at systems. We can then deliver to things like private institutions, OpenAI, Claude, and say, we think that these characteristics make models that collaborate well. Go make sure your model like meets these benchmarks or test for this or include this in your training.
Yeah, thank you. Fantastic.
Yeah, thank you. I can repeat it if you. I'll repeat it.
Well, thank you. Very important topic of model comparison that is often overlooked, especially when we compare large language models. There doesn't seem to be that openness that was also evoked in the previous talk. No? There is openness within code, but not so much in the evals. And that, I think, is very important. But there is a fundamental question I would like to ask you about multi-agents, no? Because multi-agent models, in a way, are like ensemble models, no? Like model averaging. And typically, we know that mathematically, when you combine models, that combined model is better when models are diverse. No? So as you said, if you have a good model, that good model looks for a bad model because they are genetically different. No? So that is a fundamental question on which that tell us that we should change objectives, aims, that we give, instructions that we give to the agents. No? For example, not to minimize predictive error, but do something different. Because otherwise we fall into the trap of diversity.
Yeah, I'm not sure I quite understand the core question, but the idea of typically when we think about agents and we think about the performance of agents, whether that's a human agent or we think about society as a whole, you have this idea that diversity can breed innovation, can breed increased performance. You have these opinions, they challenge each other, LLM as a judge, ensemble models, that kind of thing. This is what you're talking about. I think there's an open question about whether we can have better performance through combinations of more skilled, different, like more narrow models or different perspectives behind models versus just scaling up our individual models. I think that is something that we need to ask. I think that's something that we need to interrogate. And I would really encourage asking that to make sure it doesn't happen by accident. And I think that is one of these key failure modes or risks, is if we get more powerful models or situations like AGI or ASI as an accidental result of multi-agent system interactions, that is a bad thing. I think generally we would have less control over like the deployment of AGI, or it would open up new risks. And so what I think we need to ask is, can we achieve better performance through a number of narrow models combined and well coordinated in optimal ways than we can single performance and just scaling up single models? And I think that's an open question that we don't have great answers to. Thank you. Thank you.